They plan was to knock me out the top of the game, but I overstand they truth is all lame. I hold cannons that shoot balls of flame right in they fat mouth, then I carve my name.
Hi, I'm John. I'm a chemistry graduate student at UCLA, and now in this video we're going to be going over some chemistry topics. Hope you find this useful, and good luck in your course. So the first example of a non-covalent molecular force that we're going to be talking about is the anion-cation non-covalent intermolecular force here, so electrostatic attraction. So again, from just a moment ago, the boiling point of sodium chloride here is over 1,000 degrees C, 1,413 degrees Celsius. Now this boiling point is so high because this anion-cation interaction is a strong force. So all of the non-covalent interactions that we're going to be talking about here, I'll be labeling them basically as strong, medium, weak types of forces. So this type of interaction occurs when two ions of opposite charge are attracted electrostatically. Now the greater the charge difference, the stronger this attraction is. Now when evaporation or melting occurs in these types of compounds, you get separation of the opposite charges. And so sodium chloride will evaporate into the sodium ions and the chlorine anions separately, not as individual sodium chloride species. So that's why this boiling point is so high, because of such a strong force, such a strong attractive interaction between these positively and negatively charged species. It takes a lot of energy to separate them completely. And so that's why high boiling point and melting point is typically common for ionic compounds such as sodium chloride. Now this type of ionic bonding interaction is very distinct from covalent bonds. So in its most general definition, the chemical bond itself is the sharing of an electron pair. The ionic bond has highly unequal sharing of that electron pair, whereas the covalent bond has approximately equal sharing of the electron pair. Now the degree to which a bond is labeled as ionic versus covalent can be seen kind of like on a spectrum. So this is very dependent on the difference in the electronegativity of the two atoms that make up this chemical bond. So with very small difference in the electronegativity between them, you have very non-polar interactions between them, and it's more of a covalent bond. However, as the difference in the electronegativity increases, the bond becomes more polar and more of an ionic type interaction. For example, the difference in the electronegativity for sodium chloride is 2.1. So this is a slightly ionic bond, but it's still a strong force, a strong attractive interaction between the anion and the cation. The next type of interaction that we're going to talk about is the dipole-dipole interaction. So this is non-covalent attractive force caused by the alignment of bond dipoles with opposite charges. Now this is a medium force compared to the anion-cation force, which was strong. Now in this one, the oppositely charged ends of two bond dipoles are attracted electrostatically. The greater the difference in the electronegativity between the bonded atoms, and high polarizability increases the magnitude of the bond dipole. Now this in turn amplifies the strength of the dipole-dipole interaction. Now, longer bonds also appear to have higher than expected dipoles, but this is because longer bonds involve larger and therefore more highly polarizable atoms, resulting in other types of forces that we'll get into later. Now let's consider the example BRF. So this compound has a boiling point of 22 degrees Celsius. So that means that it's a liquid at room temperature. Now if we look at the electronegativity difference between these two, Br and F, this can be calculated as 1.2. So, if you refer back to that chart, this is moderately polar covalent, not ionic. However, the BRF molecule is slightly more negative at the fluorine. So we can label this as partial negative over here on the fluorine, partial positive over here on the bromine. Therefore, even though it's not ionic, we have a dipole moment here forming at the fluorine. Now when a slightly positive bromine here finds a slightly negative fluorine, we get a dipole-dipole interaction, attractive interaction. Now one thing to remember here is that the strength of this attraction is directly proportional to the difference in charge between the two oppositely charged parts of the molecule, parts of those bonds. The next type of non-covalent molecular force we're going to talk about is hydrogen bonding.
Oh, 56, nigga, shut the fuck up. Fuck that nigga, run that back. Money.
Run that back, man.
What?
I gotta get out, man. You gotta run that back.
Run it back? Alright, run it back.